Hi guys, in this video as a first example we are going to find the Fourier transform of a pulse function. So here you can see that there is a function which is going to have a value of 1 from minus tau to plus tau, and this is a time domain function. So we are going to shift this time domain function to Fourier transform. Using Fourier transform we are going to shift for frequency domain. In the previous video we have already learned about Fourier transform equation. If you haven't watched that, please watch that first. I have given the link in the description, and also if you are new to this expert tutor channel, don't forget to subscribe. And here you can see that when you are getting that equation you can directly apply when you are using for Fourier transform change. So what you need to do is there is an xt, the time domain function, and you need to multiply by a certain function. It's going to be e to the power minus 2 pi j ft into dt, and you should integrate from minus infinity to plus infinity. But the important thing in this function is from the minus infinity to minus tau, it's having a value of 0, which means instead of this xt, we are going to substitute the value of 0 from minus infinity to minus tau. So what I can do over here is I'm going to separate this portion. So from minus infinity to minus tau, because the xt value is having some similarity from minus infinity to minus tau, which is going to be a constant function which is having a value of 0. So it's going to be like this. Likewise, you can actually write it for other two. So now I have written all the functions and their portions. So actually you can see from the minus tau to plus tau, it's going to have the value of 1. So instead of xt, you are going to substitute a value of 1. Likewise, from the plus tau to plus infinity, it's going to have a value of 0. So if you integrate this part, which you can directly tell it's going to be 0, because if you multiply it by any functions, it's going to be 0 if you multiply by 0. And if you integrate that again, you are going to get the value of 0. So this part is going to be 0, though the balance part is going to be this, which means you can remove this 1 and directly write you need to integrate e to the power minus 2 pi j ft from minus tau to plus tau. So now this is a balanced function. If you integrate the e to the power minus 2 pi j ft, you are going to get this function. It's very simple. It's like if you are integrating an e to the power x function. If you integrate e to the power x, again you are going to get e to the power x, but since there is a coefficient before this x which is going to be minus 2 pi jf, you need to divide it by minus 2 pi jf. So it's kind of a e to the power x function. You can directly write it on, and after that you need to substitute these values from these limits. But what I'm going to do is, since there is a minus sign over here, from here there is a minus sign, so if you shift this minus to plus, what you can actually do is this limit will exchange their position like this. So it would be a little bit easier for you. So what you can do next is you can directly substitute these values. Now we have substituted those values, and there is, you can stop it over here because there is only f and tau is a constant. So if you change these f values, you can figure it out what the xf of this function. But the thing is, you can actually even simplify this function so that you can figure it out what's the relationship between those functions. So how you can do this? Before that, you need to know some equation of sine theta and cos theta. These two are the equation of cos theta and sine theta which you can relate from a complex point of view. So if you consider cos theta, it's going to be e to the power j theta plus e to the power minus j theta divided by 2. Likewise, you can write it for sine theta. Here, can you find out what's going to be this? What you can get from this, whether it's going to be sine theta or cos theta. If you divide this pi f in that side, and if you separate these portion, you can find a similarity with this sine theta equation. Instead of theta, there is 2 pi f tau. So instead of theta, there's a 2 pi f tau, and otherwise all are similar. So what you can do is, instead of sine theta, you can write it as sine 2 pi f tau. There is a balance which is going to be pi into f. You can simplify this function into more. So for that, you need to know another equation. That's going to be sinh function. Sinh theta is equal to sine theta divided by theta. So there is a function called sinh. It's kind of a sine, but it's having definitely different graph than sine. So let's look at it later. And the important thing is, we are going to change this function to sinh function. Can you find how to change this? So it's very simple. Just try to figure it out. We can actually write it all like here. So divide it by 2 tau and multiply it by 2 tau, and you are going to get, sorry, this is going to be sine. So if you do this, you are going to write it as sinh function. It's going to be sinh theta. Instead of theta, we are having 2 pi f tau into 2 tau. So now let's try to figure it out how the graph is going to be. So first of all, we actually knew that it's going to be an XF graph, which means we have already used the Fourier transform. That's why the domain has shifted from time domain to frequency domain. So this is going to be the same function as xt, but what we have done is we have changed, or we have shifted the domain from time to frequency. So now you can substitute these values and draw a graph. So first, let's assign a value of f is equal to 0 and figure it out what's the value of xf when f is equal to 0. So if you substitute the value of f over here, which means if you substitute over here, you are going to get sine 0, which means sine 0 is equal to 0 and divided by 0. By using the sandwich theorem that we already proved, that this, if the f, which is going to be this domain of this function, so if this f tends to 0, this function sine theta divided by theta, which we can represent it as sinh theta, is going to be 1. So using the sandwich theorem, you already knew this. So what you can do is, when the f is equal to 0, you can consider this portion as 1. So if you multiply by 2 tau, you are going to get the value of 2 tau. So that's the first thing you need to know. Let's substitute the value of 1 over tau now. If you substitute f is equal to 1 over tau, which means the sine would become sine 2 pi, because f into tau is going to be 1 again, so sine 2 pi, which is going to be 0. So underneath that, we are going to get 2 pi, and f into tau is again 1. So if you multiply or divide the 0, actually you are going to get 0. So when f is equals to 1 over tau, you are going to get this xf as 0. Let's substitute the value of f is equals to 2 over tau and check what's going to be the answer. So if you substitute these values, you are going to get sine 2 pi. Instead of f, you are going to put 2 over tau, which means sine 4 pi will be the balance. Actually, we knew that sine 4 pi is 0. So again, at this 2 divided by tau, you are going to get 0. And you can check it with many values. And also, if you substitute the value of f is equals to 1 over 2 tau, you can actually substitute over here. Definitely it's going to return the value of sine pi, and definitely it's going to be 0. So even for sine 1 over 2 tau, it's going to be 0. So now we have some values, and even if you want, you can actually find it for some other values like 3 over 2 tau and check how the graph would be. If you do so, you are going to get a graph like this, a symmetry graph, and you can see that it's going to be 0, going to get the value of 0 again and again, and it's going to be like this. So that's the important thing. Let's say when you are increasing this tau value, what would happen? If you are increasing this tau value, actually you can directly tell if we are increasing, which means it's going to be like this. If we increase the tau value. So let's check how it will affect this Fourier transform is this tau value. If you are increasing this tau value, what's going to happen is the 1/2 tau will decrease so that it will become more steeper and more steep. So it's like this. So once you are increasing this one, these 2 tau, these will move towards this y-axis. Likewise, these points will move towards y-axis. So always remember, when x, the tau is increasing, it's going to be like this. So let's say if you are having a unit function, which means if you are taking that tau is going to be infinite in both directions. So what would happen? Since we are just taking the tau, we are increasing the tau, and now we have considered that the tau is going to be infinite. So which means the xt would be 1 throughout the time axis. Since we have taken the tau is going to be infinite. So once you bring like that, if you substitute the value over here, you are going to get like this. If you substitute this infinite instead of tau, you are going to get like kind of a 0. So which means you are going to get an xf value which will all become in this position, and it's going to have like this. Since these points will come closer to and closer to this y-axis, and at the infinite point we are going to mark it like this. So what's the name of this function? It's having a special name which is known as direct delta function. Direct delta function. So the Fourier transform of a function which is going to be 1, if you Fourier transform it, you are going to get a direct delta function. So that's the important thing you need to notice. In the simple terms, you can actually and you can easily elaborate on this point. Let's say if there is a simple line, a straight line like this, can you figure it out the frequency of this line? Actually you can't, because there is no strict frequency. So in this case, if you do the Fourier transform, you are going to get there is no frequency, f is going to be 0. And that's why there is only one plot in this f is equal to 0. So the important thing you need to learn from this Fourier transform is not the mathematical calculation, it's just the idea behind this, how it's transforming to frequency domain, how it's going to shift, and how the frequency domain, in the frequency domain, that time domain signal will appear. So that's the important thing you need to identify. You should able to explain how it's showing like that, rather than doing mathematical operation directly. So that's the important thing of learning this module. I hope you have enjoyed this lecture. If you have any doubts, please comment it below. Thank you for watching.